Okay, Assalamualaikum and hi everyone. I am your lecturer for subject differential equation. My name is Dr. Rahima Mahad. So today uh, I would like to share with you about chapter 1. Okay, this one. Okay, so today this is about chapter 1. Chapter 1 for differential equation, but before that, is there any table of contents? Yes, this is the table of contents for this chapter, where there are 5 chapters. There are 5 chapters, and I think this is only chapter 1. So we will just go through chapter 1 first. Chapter 1 is about the basic definition of the terminologies and types of first order ODE and methods of solution. This is for the chapter 1. There are 3 subtopics here, but mainly 2 subtopics, 1.2 and 1.3. And 1.3, these are the 1.2 is about the methods of the solution for first order differential equation. And then after that, 1.3 is about the application of first ODE. So we will go one by one. Okay, so this is the basic definition and terminologies, where differential equation is any equation which contains derivative, either ordinary derivative or partial derivative. So but for your subject here, we are focusing on ODE, ordinary differential equations, where for the ODE may contains one or more dependent variables, and that one is with respect to one independent variables. Okay, these are the example here. Dependent, so before that you need to identify which is dependent and which is independent. So this is the example. dy over dx is equal to 2x plus 3 here. Okay, I think I want to change to this one. Yeah. Okay. dy over dx is equal to 2x plus 3. So from here, we can see that y is dependent, because if we want to get the answer dy, it depends on the derivative of x. So x is the dependent. It's not depends on y, but y is depend on x to get the answer. Okay, so from the second question is d squared y over dx squared. So this one similar, where your y is the dependent variables and your x is the independent variables, and similar to the example for 3. Okay, and then for the partial differential equation PDE involve one or more dependent variables. For ODE, involve one variables only. However, for PDE, involve one or more dependent variables and two or more independent variables. Okay, means that for example in this one, for for x, there are more independent variables. If you can see here, u is the dependent variables, and for the independence, there are more than two, means that your x and y, that is the independent variables. Similar to this one, u is the dependent variables, and your x and t is the independent variables. And the last one here, u is the dependent variables, and x and t, this one is, sorry, this is t. X and t is also the independent variables. Okay, so by the previous example here, so hopefully you can answer this one. Which is the dependent variables and which one is the independent variables? So from this one, the dependent variables is the w, and the independent variables is the x and t. All right. Similar to this one, dependent variables is u, and the independent variables is x and y. Okay, so we also need to know what is the order of the differential equation. So the order of the differential equation is determined by the highest derivative. Okay, so if you look from the first equation here, the highest derivative is x, and x is for x power of 1. So that's why this is 1. And okay, and then for the highest derivative is 2 here. 2, so means that this is the order is 2. Okay, and for the last one here is the highest derivative is 4. So this one must be 4. Okay. Okay, and then for the exponent of the highest derivative, this is the exponent. So the exponent of the highest derivative, you have d squared y over dx squared plus 3 dy dx plus ay is equal to 0. So from this one, the highest the exponent of the highest derivative is 1. And this one is also 1 because y is 1. And this one is 0 because there is no y there. Okay. Okay, maybe this one you can try it later. More the example here. What is the order and the degree? Okay, and then we go to the linear differential equation. Linear differential equation means that the derivative degree is 1. Okay, each coefficient of the derivative depends only on the independent variables. Okay, so from this one, this is the example here. The dependent variables and their derivative. Dependence means that the upper part, so that is degree 1, and each coefficient of the derivative depends only on the independent variables. Okay, so for this example that we can see this is a linear equation. For the linear equation, and because the highest power is 1. However, for this one, this is non-linear because the derivative of dy dx is not 1 here. This is power of 4. Okay, and this one is also non-linear because you have the x squared and x cubed. And this is also nonlinear because the function is sine, and you can determine whether the last equation is linear or non-linear. Okay. So non-linear differential equation is other than linear equation. So by linear and non-linear equation, we can solve by using the initial and boundary value. Initial condition means that will be given on specific given point, and for the boundary condition will be given on some point. Okay, initial means that for the early time, usually your time is equal to 0. This is the initial condition where usually your time is considered as 0. And for the boundary condition, for any time given on some point. Okay, this is for the initial value problem, and this is for the boundary value problem. Depends on the point given to you. Okay, and then how we want to solve the first order differential equation, ODE. There are how many types here? 1, 2, 3, 4, 5. 5 types of ODE. Okay, so first we will go to the separable equation. How we want to solve by using the separable equation here? Means that you can separate the equation. Okay, so if how we want to identify? Suppose that fxy is equal to dy over dx is equal to ux vy. So if we want to separate the equation, it can be written as dy over vx. Means that this one you can move to the other side, and your dx you can move to the right hand side. This means that you can separate the equation. Okay, so it will become the equation, the second equation here. And how you want to solve? You need to integrate. You need to integrate both sides of the equation. You need to integrate. You do the integration, and then after that, you can get the answer. Okay, but before that, before we proceed with the complete examples, maybe you can try how you can separately the equation, this one. Example for E here, how you want to do the separation? So you need to separate between X and Y. That is the mean of the separation there. So for this one, dy over dx equal to secant square y over 1 plus x square. So your x you put into one side, and your y you put into one side. So this one you can have 1 over secant square y dy equal to 1 over 1 plus x square dx. Okay, and then after you get this one, you can do the integration part. Okay, you can do the separately lah. This is how you want to separate the equation. Okay, let me check first. Okay, and then after that, you can try the other number as the other example here. Maybe you can try B, C. You need to separate between, for B, you need to separate between V and X here. Okay, similar to C, D, maybe you can try later. This is your A. Okay, we go to example 1. Solve the initial value problem where dy over dx is equal to y cos x over 1 plus 2y square, where the initial value problem is y0 is equal to 1. Okay, and then see, how you have to solve this one? Okay, your first step is you need to separate the function. So from this one, because there is your x and y, so you need to separate between x and y. So we get cos x times with y over 1 plus 2y square. Okay, okay, and then after that, you put your y into one side. So we put y into the left hand side. 1 plus 2y square over y dy equal to cos x dx. Okay, and then your second step is you need to integrate both sides. Okay, you do the integration, and because this one, the first term here, you can separately do the in separate form, so you can do the integration easily to do the integration. So you will get this one, you need to put the bracket, integrate 1 plus y plus 2y. 1 plus y plus 2y dy is equal to cos x. Okay, and then integrate 1 over y, we get ln y. Ln y is equal to y squared equal ln y plus y squared equal to integrate cos, we get sin x plus c. Okay, because in the question already given to you, the initial value problem, y0 is equal to 1. So you need to substitute. Your x is equal to 0, your y is equal to 1, like this. Okay, and then you substitute into the equation here. Ln 1 plus 1 squared is equal to sin 0 plus c, because you want to know what is c. So after you do the substitution, your c is equal to 1. Okay, and then you substitute back c with 1. So this is your final answer. This is the final answer here. Some DE may not appear separable initially, but through appropriate substitution, the DE can be separable. Okay, so you need to check first. Sometimes it's not directly you can do the separation. However, you need to use the substitution. Okay, do the separation. Okay, this is the example 2. Show that the differential equation dy over dx is equal to x plus y squared. So if you look from here, but there is another information that can be reduced to a separable equation by using substitution. Z is equal to x plus y. Okay, so from the first ODE here, you can see that it's not easy to separate between x and y. So that's why given to you the substitution. Z is equal to x plus y. And differentiate, how are you to solve this one? Differentiate both sides with substitution with respect to x. So we get, first we start with the substitution. Z is equal to x plus y. And then you differentiate. You differentiate, so you will get dx, this one in respect to x. So dz over dx is equal to 1 plus dy over dx. So you want your dy dx. So this one you move to the other side. Okay, so dy dx is equal to dz minus 1. Okay, and then substitute into dE. What is your dE? This one, dy dx. So you substitute dy dx into the dE here. So you will get x plus z, you substitute with z. X plus y, you substitute with z. You substitute the substitution into the dE. So you will get this one. Okay. dz over dx minus 1 is equal to z squared. Okay, and then write into separable form. So dz, this one you only have two variables here. So you can separately, easily lah. So your x here, X you move to the other side, and Z you move to the left hand side. So you will get Z square plus 1. This one 1 over Z square plus 1 dz is equal to dx. Okay, after you separate the variables, then you need to do the integration. Integration for both sides. So 1 over Z square, the integration is tangent inverse Z is equal to integrate 1 is equal to x. So you will get, you substitute back your Z with x plus y. Okay, and then you can get the x plus y is equal to tangent x plus c. Okay, you cancel the tangent by, you times the tangent here. Tangent inverse x plus y is equal to tangent x plus c. Okay, and then you can get your y. Y is equal to tangent x plus c minus x. So this is the answer here. But no, this is but for this question there is no initial value problem or point or the boundary value problem pointer. Okay, and then this is the question from the past year. Maybe you can try to solve how to solve the initial value problem by using the method of separation. So you need to remember that if a method of separation means that the first thing you need to do the separation between the variables, and then after you manage to separate, you need to do the integration. And the last one is if there are given to you the point, so you need to substitute the point. If not, you just let the answer be like that. There you need no need to find the C here. Okay. And if the question is given to you with the what we call the substitution, so you need to use the substitution. Okay, to solve the DE. Okay, this one, for example, this one given to you the substitution, so you need to use the substitution to solve the IVP here. Okay, maybe you can try to do later. I will show you the first one, the first question here. Solve the following initial value problem where dy over dx is equal to x plus y, sorry, xy plus x over y, where the initial value problem is y2 equal to 0 by using the method of separation of variables. So this is the question. The first step is you need to separate y and x. So you separate, you move your your y to the left hand side and your x to the right hand side. So you will get the second step here. Y integration y over y plus 1 dy is equal to x dx. Okay, and then for the first term here, you need to do like in the red one here. You need to divide. Okay, so you will get y divided by y plus 1. So 1, y plus 1. So you get this one. The appropriate, what we call the appropriate function here. So you get 1 minus 1, 1 minus 1 over y plus 1 dy is equal to integration x dx. Okay, and then after that, you do the basic integration, you will get y minus ln y plus 1 is equal to x squared over 2 plus c. Okay, after you got the last step, you have your c here, you need to substitute back. What is the point given to you, the initial value problem? Y2 is equal to 0. So your x is equal to 2, y is equal to 0. Okay, so from here, you substitute. Use y2 is equal to 0 to get c. So your x is equal to 2 and y is equal to 0. You substitute. So you can get your c. C is equal to negative 2. Okay, this one 4 divided by 2. 4 divided by 2 is 2. You move to the other side, you get negative. Okay, so the final answer is you substitute back your C into the equation here. Okay, that is how you want to solve. Maybe you can try later. Number 2, 3, and 1, 2, 2, 3, 4, 5. Okay, the rest of the question. Okay, next is the homogeneous equation. How to identify? Suppose fxy is equal to dy dx, and fx is homogeneous if f lambda x, lambda y is equal to fxy. If you times your point here with lambda, you will get the question back. Okay, for every real value of lambda. Okay, what is the method of the solution? Determine whether the equation homogeneous or not. Okay, and then first you need to determine if homogeneous, so means that you can find this one. But however, if you want to determine whether the equation is homogeneous or not, you may use this method. Okay, how you want to use this method? You substitute your y is equal to vx, and dy dx means that you need to differentiate this function. Your v, you get dy over dx is equal to v plus x dv dx in the original dA. Okay, and then after that, you separate the variables of x and v. Similar to the previous method, that you need to integrate both sides and use the initial condition if given to get the constant value. These are for step 3, 4, 5 are the separable equation method. Okay, so how you want to solve this one? Determine whether the this one is you want to check whether the DE is homogeneous or not. Okay, so your first step is you need to times your x and y with lambda. This is the equation. Whether you want to check whether you can get fx again or not. Fx means that you need to get the x squared plus y squared over x minus y, x plus y. Okay, and then you substitute with lambda x, lambda y into the equation here. We get the second step here. You do the substitution with lambda x and lambda 1. Okay, and then after that, you do the factorization with the lambda. So you get lambda square over lambda square. So you can cancel the lambda. And if you cancel, you can see that you can get back the question, the equation similar to fxy. So from here, we can conclude that this function is homogeneous. Okay. And we go to B. The question is dy dx is equal to y over x plus square root x square plus y square. So, like the previous example, that you need to substitute with lambda x and lambda y. So, you substitute into this equation, lambda y over lambda x plus lambda x square plus lambda y square. However, the first term here, you can cancel the value of lambda here. If you look here, this one, you can cancel the term lambda here. However, this one, you factorize and you bring out the lambda. So you just get the lambda here. And if you compare from the equation and what you get from the until this calculation, that is not equal, because there is an extra lambda here. So from here we can see that f lambda x lambda y is not equal to f xy. So the DE is not homogeneous. Okay, that is for B. This is example 2. Solve from the homogeneous equation, you can solve the question is solve the homogeneous. So if given to you, stated to you that this equation is homogeneous, so you no need to check whether the equation is, you no need to check whether the equation is homogeneous or not. Since it is stated that the equation is homogeneous, therefore don't need to check for the homogeneity. So we just substitute with y is equal to vx and dy over dx equal to v plus x dv over dx. Okay, so you substitute into this equation. So the first one here, you move to the other side. You move to the other side, so you will get this one. And then dy over dx, your dy, you move, sorry, your dx here. Dx, you move to the right hand side here. So dy over dx is equal to your x square, you move to the other side. So you will get y square plus xy over x square. You will get this equation. Okay, and then you do the substitution, what already given to you. Your dy dx is equal to v plus x dv over dx is equal to, and you substitute what is your y. So your y is v square x square plus x vx over x square. Okay. Okay, and then after that, this is your, this one you need to simplify. So you will get, you need to take out your x square. This one you need to factorize. So you get x square bracket v square plus v over x square. So you can cancel the x square here. So that's why you get v square over v. Okay. And then after that, this one you can cancel v here and v here. So that's why the balance is x dv over dx is equal to v squared. Okay, and then after that, you can start to separate the variables. Okay, where your x you put to the right hand side and your v you put to the left hand side. And you do the integration. So you get this one, this step. Okay, and then use integration v squared, you will get v negative 1 over negative 1 equal to integrate ln 1 over x is equal to ln x plus c. Okay, and then negative 1 you bring downside to the denominator, you will get negative 1. This one you will get negative 1 over v equal to ln x plus c. Okay, and then you substitute back v with y over x. Okay, you substitute back v here. V is equal to y over x. So you will get negative x over y. You substitute into here equal to ln x plus c. So your y is equal to 1 over x times with ln x plus c. Okay. So how am I to do this one? So you will get this one, you will get negative x is equal to y ln x plus c. Okay. So this one is equal to y is equal to negative. We move to the other side. This one you will get negative x over and we change the value here. Wait, we get negative x over y. X over y is equal to ln x plus C. So I will write 1 over Y is equal to 1 plus C. Okay, so this one you will get Y is equal to negative 1 over X ln X plus C. So non-homogeneous can be reduced to a homogeneous equation by using the right substitution. Okay, and then we go to the example 3 here. Find the solution for this non-homogeneous equation. This is already mentioned to you that this is non-homogeneous where dy over dx is equal to y minus 2 over x plus y minus 5 by using the following substitution. X is equal to capital X plus 3, y is equal to capital Y plus 2. So this one you need to by using the substitution. Okay, so how you to do this one? By using the substitution, you need your x is equal to x plus 3. So you need to differentiate with respect to x, capital X here. So you will get dx over d capital X is equal to 1. Okay, and then you bring your dx to the other side. You will get dx over d capital X. Similar to y, this is your y, and then you differentiate dy over dy is equal to 1. So dy is equal to d capital Y. Okay, and then you substitute 1 into the equation 1 here. So you will get dy over dx is equal to dy over dx. Dy substitute into 1. So you get dy over dx is equal to, you substitute your y here with y plus 2. Y plus 2 minus 2 over your x is equal to x plus 3 plus y plus 2 minus 5. Okay. And then you simplify, you get y, capital Y over x plus y. Okay, and then proceed with a normal step of homogeneous, where you substitute with y is equal to vx and you differentiate y is equal to dx with this one. You get this one. And you substitute into this function. dy over dx is equal to dy over dx is equal to vx plus dv over dx ni. dv v over x dv over dx equal to, what is the function here? Y over x plus y. Okay, so your y is what? Vx. Your y is Vx. And then y over x plus y. X, what is, your x is x plus y. Y is Vx here. This is your y. And this is your y. So that's why this is Vx, Vx. Okay, and then your x dv over dx. So your v, you move to the other side. So you will get v over 1 plus v minus v. And you simplify the right hand side here. You times with 1 plus v. Like this, you times with 1 plus v. And then you simplify. So you will get negative v squared over 1 plus v. Okay, and then after that, v, you substitute your 1 plus v here, dy dx. One, you after you get this one, you need to separately between your v and x. This is v plus x dv dx is equal to this one, v squared over 1 plus r. V squared, negative v squared over 1 plus r. You substitute into which one? Integrate 1 plus v over v squared dv is equal to integrate negative 1 over x dx. Okay. Okay, and then after that, this one you simplify. Not you simplify, you separately. You separately 1 over v squared plus v over v squared dv is equal to integrate negative 1 over x dx. Okay, and then this one, integrate v negative squared, you get this one. You get the next step, and integrate 1 over v, you will get ln. And this one also ln, negative ln x. Okay, and then after that, this one you just rearrange. You need to plus c. You need to rearrange this one because we want to put ln with ln. So ln v plus ln x is equal to c plus 1 over v. Okay, and then after that, plus, because ln plus ln, this is from the properties of ln, it will become ln vx is equal to c plus 1 over v. Okay, and then from here, vx is equal to exponent c plus 1 over v. Vx is equal to, because this one you put, we want to eliminate ln here. So exponent and ln, it can be eliminated. So you exponent both side here, exponent ln, and you exponent this one as well. Okay, you exponent this one. So you will get Vx here. Vx is equal to exponent c plus 1 over v. Okay, and exponent c is constant. So you substitute with any, because it's just want to make it easier. So your a is equal to exponent c. So that's why this one is your a. A is equal to, so Vx is equal to a. This one you will get exponent c times with exponent 1 over v. Exponent 1 over v. So EC is equal to a. So that's why you get in here exponent 1 over v. Okay, and then after that, your v, you need to substitute back with y from the question here. This one, not from the question, from the substitution here. V is equal to y over x. So you need to substitute back your v is equal to y over x for both sides. And then this one you can cancel the value of x. So you can get y. Y is equal to a exponent x y over y. Okay, and then after that, you substitute back. What is your capital Y? Capital Y is y from the substitution. Capital Y is equal to y minus 2. So this one, y minus 2 is equal to a exponent. You substitute what your capital X and capital Y. Okay. And then after that, you move your 2 to the right-hand side. You move to the right-hand side. So you can get the answer of Y. Okay. Okay. These are the questions from the past year test 1. Okay, you can try by your own how to solve the DE here. For the first question, it's already stated to you this is homogeneous, so you no need to check about the homogeneity. Okay, for this question 2, already stated to you that this is homogeneous, so you just need to find the sorry, for the question 2, that you need to show that this DE is homogeneous, and then after that you need to find the solution. Okay, similar to number 3 as well. Okay, you can try later. Okay, I think we will stop until here, and for the next class we will go to the next subtopic, which is the exact solution. Okay, that's all for today. Thank you. Assalamualaikum.